4, last unit, we had this theorem that says if I had an exterior angle of a triangle, I could find the measure by so the old theorem was angle 1 was equal to, anybody remember that theorem? Any exterior angle of a triangle, it's already up here, but see if angle 3 and angle 4, and we called angle 3 and angle 4 remote interior, the ones that were not next to the exterior ones. Yes. So what I'm going to do today is take that theorem and make a new one that says, wait a sec, whoa, if the exterior is equal to the remotes added together, shouldn't the exterior by itself be bigger than either of those two separately? So angle 1's just bigger than angle 3 by itself. And I can also say angle 1 is bigger than angle 4. Because again, if 1 is the same as adding those two, shouldn't 1 be greater than those two separated? And the answer is darn right. So exterior angle is always greater than either of the two remote interiors. That's our first theorem for today. Okay? Exterior angle of a triangle greater than either remote interior. Now, I do not, this drives me nuts, do not know the relationship, which one's bigger or smaller between those two. I'm not going to say by the looks of it either. Okay, the exterior angle is not always greater than its linear pair. All right, so please do not, this does not include those two. I do not know which one's bigger. Good deal? All right, let's apply this. A lot of group time today, a lot of group time. I know you're excited. I want you to look at my diagram and find all angles, not just one, because there's more than one. All angles less than angle 7. All angles less than angle 7. So if you take a look, I'll start you on the right track and I'll leave it to you and your group. Angle 7 is an exterior angle, isn't it? Of two triangles, I believe. I see its exterior for triangle MKL, and I see it's an exterior angle for LJK, those two triangles. You and your group right now, find me all the angles you can that you think are less than exterior angle 7. And if you want a challenge, I found 5. I have found 5 that are less than angle 7. Talk it over in your group. I have found 5. Name all the angles that are less than exterior angle 7. So talk it over. Let's go. Let's go. So take a triangle that angle 7 is exterior for and find its remote interiors. And those will be less than 7.
Yes, that's not an exterior angle. Number 4 is not an exterior. Yeah, I know 4. I got 4. I have 5, 3, 4, 2.
5 angles.
Wait, 3? We said 2. We said 2 because it's greater than 2 plus 4. 7 is greater than 2 plus 4. So it's got to be greater than 2. So right now we have 5, 2, 1, 2.
All right, let's talk. Angle 7. Exterior angle for triangle MKL? Everyone agrees. 7 is exterior to it, which means, all right, what are the two remote interiors then? It would be angle 5 and angle 4. So 7's got to be bigger than 5 and 4 because those are the two remotes. All good so far. Go to a new triangle that has 7 as exterior. Triangle JLK, where 7 is exterior. So 7 is exterior. One of the remote interiors is 3. The other remote interior is JKL. So all I've done is listed 4 remote interior angles. All good so far. So where did I come up with the 5th? Look at JKL. 7's already bigger than the whole angle. So shouldn't 7 be bigger than its parts? Which would be angle 4, I already have that, and angle 2. Okay, 7's bigger than angle JKL, so it should be bigger than its parts. Questions there? Now let's go to question 2, same diagram. Now I'd like you to find all the angles that are greater than 6. Greater than 6. And there should only be 2 that you can find. 2 that are greater than 6. So now you're looking for 6 is a remote interior for this exterior angle. All right, so see what you can have. 6 looks like it's interior, so find an exterior that would be greater than. Now I got 2 here for you, only 2.
1. And then 2 down 1. Right, 1 and 2.
Oh, shoot. 6.
Wait. So we got 1. Nothing else goes off except 7.
What was the other one you said? It's like it's the same as 7.
JKL.
It's the same as 7. It's just not right. You're doing this.
Think we found something? All right, let's see. All right, first triangle I see where angle 6 is in there is triangle MKL. And exterior angle is angle 1. Do that again. Oh, or not. Come on. There we go. Everyone see exterior angle 1 there, where 6 is a remote interior. So angle 1 is bigger than it because it's an exterior angle. Also, angle 6 is part of another triangle. It is part of triangle LKJ, the big one. And if you notice here, angle 8 would be an exterior angle, where 6 would be the remote interior. So angle 1 and angle 8 are the 2 angles. Question, because I haven't even gotten to the honors one yet. Any questions here? All right, let's try out the honors one now. Multiple choice honors one. So in triangle ABD, take a look. AB is congruent to BC. AB, you doing anything right away? Oh, that means boom, mark it. Where are you marking on your diagram now? If those two sides are equal, the angles across, angle 1 and angle BCA are congruent. That'll help you in this problem. All right, which one of this is true? Is 1 bigger than 2, 1 bigger than 4? 3 bigger than 4 or 4 bigger than 2? Go ahead, keep discussing in your group. See what you can do here. And again, we're using an exterior angle bigger than its remote interiors. And there's a reason why I gave you it was isosceles.
Why is it greater
Talk to each other. Don't say it by the looks of it.
because
Have an explanation for me.
BAC is greater than BC. And like since it's remote interior.
Let's go. We can do this. We can do this. You better be able to explain yourself other than it looks like it. And why did I even give you the sides were equal?
Which one is well, this is an exterior. So 3 and 4.
Woo!
3 and 4 is. So this is
Challenging you here, huh?
This is greater than 3 and 4. So that means that 1 is 2, right? Because this is greater than this. And this is greater than this.
Oh,
Right?
oh, so that would be minus 4.
1 is greater than 4.
I like some of the talking I'm hearing. Let's go to the board now. Let's start with angle BCA, everybody. Angle BCA. You may not see it, but it is an exterior angle for triangle BCD. We see that. It's an exterior angle. So that means BCA is bigger than angle 4, and it's also bigger than angle 3, right? Agreed. All right, well, I'm going to do a little thing called substitution here. BCA is also the same as angle 1. So it's the same as plugging in angle 1. So angle 1 is also greater than 4 and 3, but I only have one multiple choice, and that's angle 1 greater than angle 4. All right. Questions there? Good one. Yeah, I know. Honors level. All right, so today's 2 theorems. That was the first one. The second one you're going to find out in your groups right now. So you've noticed I've given you 2 triangles. Both triangles have a missing angle. Right quickly in your group, can you find the missing angle for both triangles? And then we'll come back up here. Can you quickly find the missing angle for both triangles? Yours are drawn to scale, mine are not. So what do we have? 42 and what's the other one? 35. All right, now I'm going to give you a little bit longer time to have a discussion in your group. Do you see a pattern between the sides and the angles of each triangle? Do you see a pattern between the sides and the angles? And I don't mean to find this side, you double the angle and subtract 8 from it. I don't mean that. Just look at the sides and the angles and see if you see any relationship or pattern between them. And it works for both triangles. So I'm giving you 2 different triangles to look at. Do you see any pattern between the angles and the sides?
56 between like the 2 biggest sides. It's the smallest one. 7, 35, 16, 5, 25.
I was gonna say,
Look like between the 2 smallest sides and the biggest side.
Anybody here so we can write it down here? So theorems, let's start here because this fact, again, only works in a triangle. Any group want to try to throw it down here for us? What's the pattern? Go ahead, guys. There it is. Okay, in any triangle, smallest side is across from the smallest angle. If you want to substitute the word bigger and biggest, or bigger in there, or biggest, works as well. In any triangle, the smallest side is always located. Take a look. 42 and 4 are across from each other. 35 and 16 across from each other. Always, always, always that'll work. So there's your second big theorem for today. So let's use it for a couple problems and then we're done. 1 and 2, list the sides from shortest to longest. You can't do that unless you know all three angles. Right? I can't rank the sides from shortest to longest until I have all three angles. So that's our first step, find the missing angle. And now I'm going to start calling on you guys. So what do we got here? Missing angle 92 degrees. All right, let me open it up to you guys. So that first diagram, triangle ABC, please rank the sides from shortest to longest. All right, need a little help here from you guys. Let's start it off right. Amy, shortest side? Because it's across from 41. Good. Next, keep going. BA. And then the longest side would have been AC. Next up, diagram 2. I gave you exterior angle 107. You should be able to find the other two angles from there. Oh boy, what's that? 73. 148. 32. How do my angles look? They look all right? They look good? All right, rank them for me. Smallest one, shortest one. 1-5, Gabby, smallest one. Followed by, go ahead. ST, and then yes, and then we have RT there. All right, good work, everyone. In a triangle, smallest side is across from the smallest angle. All right, I think we got a couple more. Ooh, triangle ABC. I give you 3 angle measures. All right. You don't have to, but I'm just helps me out teaching you. I have one ABC. One angle's 3x. Angle B, 4x minus 19. Angle C. And I'm asking you, is it isosceles? Is this the longest side? Is this the longest side? Or is it obtuse? Well, I'm not going to know until I find the angles. And I don't know the angles until I find x. So can someone help me write an equation to find x? 1, 2, Olivia, how about an equation to find x? Good work, good work. Excellent. Equals $1.80. So go ahead, everyone, solve for x, plug it back in, and then I'll get somebody to do the angle measurements for me. So hopefully everyone's getting x equals 20. I'll give you a minute to plug it back in, and then I'll ask somebody what the angle measurements were. What do you have for your angle measurements here when you have them? That's it, Matt. Angle measurements, angle A when you have it.
60.
Yep. How about angle B?
61.
Got it. And angle C?
59.
Good work. All right, now let's look at our choices. Choice 1, it's isosceles. No, it's not. Not unless I have two angles congruent, which I don't. I don't have two angles congruent, so it's not isosceles. Let's go to choice 2. Is AC the longest side? Well, AC is across from 61. Is that the biggest angle? Yes, it is. So AC is going to be the longest side. Let me just go over choice 4. Why it's not obtuse? Because I don't have an angle greater than 90. Yep, this is actually an acute triangle, isn't it? All right, final thing now. Using this theorem in a diagram that's got multiple triangles. So at this figure, which segment is the longest? I can't answer that unless I know every angle, right? So let's find the missing angles. I can't answer that unless I know the angles. So that's 0, carry the 1, 120. This is 60 degrees. One 23. 7. Is this 57?
Yeah.
Okay. All right. So is everybody good here? Now I know most of you are just gonna be like, oh, this one's gonna be easy. I just look at the biggest angle, which is 70, look across. My answer is BC. It's not how this works. Okay, math. Now that might be the answer, but that's not how we do it. That's not how we go about it. What you just, the mindset, the process you guys just said, what I just said to you, where 70 was the biggest, look across, that's the biggest side in triangle BCD. But what am I looking for? The biggest side overall in the diagram. There might be a bigger side than BC. All right. BC, using that thinking, is just the biggest side in that triangle. Maybe not overall in the diagram. So here's how we're going to approach these multi-triangle diagrams. We're going to take each triangle, triangle ABD, and put it up against triangle BCD. And what I want you to do right now, since we're finding the longest, is take each triangle and rank the sides from longest to shortest. All right, because I am finding the longest one, so I appreciate it if the longest one is listed first. So go through each triangle right now and list your sides out. And then I'll show you how I determine the longest side, other than just saying it's across from the biggest angle, which is not always necessarily the case. How do our rankings match? All right, everyone's good before we discuss. All right, now if I'm looking for the longest side, really the battle is between the two longest sides in each triangle. All right, those are the only two. So my answer is either going to be BD or BC. And the answer is not the one that's across from the biggest angle. That doesn't know how it works here when I bounce back between two triangles. It doesn't work that way. So it's either going to be BD or BC. Look at my rankings, please. Look at my rankings. Why can it not mathematically be BC? Look at what you've written up here. I'm sorry, my bad. Why can it not be BD? Look at what we've written up here. Mathematically tell me, and don't tell me because it's across from the 70. That's an incorrect response. That's incorrect thinking. Why can I confidently eliminate BD just based on my rankings here? Go ahead, Ian.
Because you already said that BC was bigger than BD.
Look at right here where you put BD. Didn't you rank 2 other segments that are bigger than it? Yeah? Everyone agree? You said that CD was bigger than it and BC is bigger than it. So how can it be the biggest one overall if there's 2 other ones that are already bigger than it? So that tells me why, yes, BC is the biggest. But it's not always the case that it's across from the biggest side. Why? And this is exactly why I have this last example here. So go ahead, find your missing angles. And this proves my point exactly. Let's see, what's my missing angle here? That's 868, 2 more. 122? No? 112, that's better. And then this one's a little easier because that's 140, that's 40. If you use that thinking that the smallest side is going to be across the smallest angle, you're going to tell me the answer is YA, and I can tell you that's not going to be correct. Okay, the answer is not YA here. All right, so again, I'm going to have you guys do the same thing we did before, but now, since I'm looking for the shortest side, now I want you to rank them from shortest to longest. So I can see the 2 shortest ones right up top. So go through each triangle, triangle NYA and triangle YVA, and rank your sides from shortest to longest now. Again, I want to see the 2 shortest ones on top. And then I have a challenge question, a follow-up question after this, so we're not done after this. Okay, everyone have them ranked. All right, well, again, it's going to be between these 2, the shortest ones in each triangle. So it's either going to be YA or VA. But this is why we have them ranked. It cannot be one of those. Mathematically cannot be one of those. Look at YA. Don't you have, right here in this triangle alone, don't you have 2 that are smaller than YA? So there's no way YA can be the smallest one overall if you already have 2 that are ranked smaller. So instead of YA, it's going to be VA. There's your smallest one. Okay. Here's my follow-up question, honors kids. Rank all of them now. Rank all of them with me. So now I know it's VA is the smallest. What's up next? Is it VA now? I mean, is it YA? VA is the smallest. What's the next smallest one now? Is it going to be YA? Right? Because that was the 2 smallest, so it's got to be the other one. No, because again, what else do you have ranked that's shorter than YA? VA, which we already have, and YV. That's next. Now what can I put? Now I can put YA. And now out of the last 2, YN and NA, which one's the shorter one? You ranked them. Which one's shorter, YN or NA? Y. Hi. Y. N. And then the biggest one overall here is NA. Okay, that's what I'm probably going to have you do eventually, is rank them all. instead of just finding the shortest one. Questions? You have two ways you can go right now. You can start prepping for tomorrow by doing the Delta math, or you can start the assignment, but it's not due until Monday. Remember, this is not on the quiz tomorrow. It's due a week from today after break. So your call where you want to go.